स्टूडेंट, हम डिफरेंशिएशन में कुछ देखेंगे. डिफरेंशिएशन, some questions of differentiation and some concept of differentiation you did previously, correct or not? In that one, basic thing, main basic means very fundamental, I'm not going to tell you in the class, I will tell you. But yes, I'm telling you so that you can tackle the question, you can solve the question. Okay, you know the formulas, all the differentiation formula. Like first formula, if you don't know, then whoever is new, just listen it and try to write once. Okay, these are formulas that dy dx. Okay, this is called what we are, this is called differentiation. If I am writing dy dx of, let's say, f of x, it is read as what, dy dx of f of x. Its meaning is what we are, its meaning is differentiation of differentiation of f of x with respect to x. Differentiation of fx, this one here, differentiation of fx with respect to x. Okay, this is the meaning. I hope so this is clear. So see, now if I am writing, let's say, second one, dy dx of f of x, let's say one function is there, and plus g of x, second function is there. Okay, so this is the rule. So it will be, or minus is there, then it will be differentiation of fx, means dy dx of f of x plus dy dx of g of x. Okay, if here minus, then here will be minus. Okay, this is the second rule. Third rule is that dy dx of f of x into g of x, let's say two functions are in multiplication, then what will be, then its differentiation will be, okay, first function outside means fx outside, first derivative of g of x plus second function outside g of x into derivative of first function, means fx outside into derivative of gx plus gx outside derivative of f of x. This is okay. So this is the third one. Fourth one is there, dy dx f of x upon g of x, means if two different type of functions are in division, then what will be its derivative will be whatever in the denominator, that's square, g of x square. Okay, after that whatever the in the denominator, that is outside, in the numerator, dy dx of numerator function fx, and in division minus is there, minus. Now first function outside f of x and dy dx of g of x. First function I am saying this one, second this one you can say. Okay, so its differentiation is this one. I hope so. These three formulas, you can say formula, you can say, are just, it is actually theorem. Okay, rules type. You have to remember this one, that if plus minus is there, two different type function, then derivative will be separated with these two. Okay, and dy dx, if fx into gx, then what will be a first function outside derivative of g of x plus g of x derivative of first function. Similarly for division. Okay, we'll see uh, some questions in this one. First I am telling you some formulas. Okay, some more formulas, even some previous formula I am telling you. First thing, dy dx of x power n, it is formula via, it is equal to n x power n minus 1, and x is not equal to, x is sorry, x not x. Okay, I will tell you this one. Okay, first formula. Second one, dy dx of x power n is equal to n outside, x power will be reduced by 1. Okay, For example, we can take some example of this one, like dy dx of, let's say you want x square, then what will be 2 outside, x power 2 minus 1, reduce 1 power, it is what, 2x. Similarly, second one, dy dx of x will be what, we are, x means x power 1, 1 will be outside, x power 1 minus 1, so it is 1 into x power 0, that is what, 1 into 1, so this is 1, means derivative of x is what, we are, 1, derivative of x is 1. Similarly, dy dx of, let's say you are writing x power 3 by 2, then what you will write, 3 by 2 outside, x power 3 by 2 minus 1, it will be what, 3 by 2 x power, okay, 1 by 2, okay, in this way. One more rule is there, okay, formula you can say, rule you can say, this I am writing, see. Okay, one more rule is there, rule is what, that fifth one, that dy dx of k times f of x, k times f of x is equal to k outside derivative of f of x, where k is any constant, k is what, we are, constant, okay, k is constant. So if k is constant, then k will be outside and derivative we have to take only of fx. Like one example we can take, dy dx, let's say you have to find derivative of 5x, then 5 will be outside, derivative of only x, and derivative of x is what, only 1, 5 into 1 equals to 5. This you did here, derivative of x is 1, okay, and you have to remember also, derivative of x is 1, that is very simple, 1 x power 0, okay. um, this is done. One more I told you, that remember it, dy dx of under root x is important. It is what, dy dx of x power, under root means we have what, x power 1 by 2, then 1 by 2 outside, x power 1 by 2 minus 1, it becomes what, 1 upon 2 x power into x power minus 1 upon 2, I can write in denominator 1 upon 2 into x power 1 by 2, it is 1 upon 2 root x, correct now. So remember this one point, to remember, first point to remember, ptr, what, dy dx of under root x is equal to 1 upon 2 root x, okay, this point here you have to remember. One more, this one you have to remember, this is the formula, you have to remember it, okay. One more, if I am differentiation finding, let's say question, dy dx of 1 upon x, actually this one also you have to remember. Firstly I am writing this value is minus 1 upon x square, this one also you have to remember, dy dx of 1 by x is equal to minus 1 by x square. How, let's see. You are saying dy dx of 1 upon x, differentiation we have to find. So what will be, dy dx x power minus 1, correct now. So x power minus 1, you are saying that if x power n is there, then what, an outside x power n minus 1, reduce one more power, okay. So meaning what, it will be minus 1 outside, x power minus 1 minus 1, reduce the power by 1, so minus 1 x power minus 2, I can write this one in denominator, 1 minus 1 upon x power 2, means minus 1 by x square. Okay, so I hope so up to this one clear to you. Let's say I am saying find dy dx of 5x cube plus 3x square. Okay, what you will do, derivative will be separated, dy dx of 5x cube plus dy dx of plus dy dx of what, 3x square. So what will be 5 outside, derivative of x cube, 3 into x square, plus 3 outside, derivative of x square will be what? 2 into x power 2 minus 1, 1. So it become what? 5 3s are 15x plus 6x. I can take 3x common. Okay, 5 plus 5x plus 2 is the answer. I hope so in this one no problem to you. Okay, now next formula, towards next formula we are going to move. So we did 2 3 things. That what? First one, first formula, dy dx x power n is equal to n x power n minus 1. Okay, after that, second formula I am writing, if dy dx of any constant function, you are taking derivative constant, then it will be 0. Okay, it will be 0, means like dy dx I am saying of 100, what will be? 0. dy dx of n I am saying, n is a number, na, it will be what? 0 will be. Okay, dy dx, let's say I am saying log n plus 1. So log n is also constant and plus 1 is also constant, total is constant, total differentiation will be 0. Okay, third one, third formula, dy dx of log x is equal to 1 upon x. Okay, fourth formula, dy dx of e power x is equal to e power x. Fifth formula, dy dx of a power x is equal to a power x log a base e. Okay, sixth number formula, dy dx of, this way any other formula is not there, log x e power x a power x. Okay, after that, okay, after the trigonometric formulas are there, dy dx of sin x, differentiation of sin x with respect to x will be cos x. 7 number formula, dy dx of cos x is equal to minus sin x. Okay, 8th number formula, dy dx of tan x is equal to sec square x. 9 number formula, dy dx of cot x is equal to minus cosec square x. 10th number formula, dy dx of cot x done. After that what? Sec x. Sec x formula, sec x tan x. Okay, sec x tan x. 11 number, dy dx of cosec x. Yeah, you have to remember this one. Okay, minus cosec x cot x. If you are thinking without remembering this formula, you can tackle the question, then forget about that one. Okay, formula, these formulas are very simple and very fundamental formulas of differentiation. Okay, so at least this constant differentiation 0 log x differentiation base e should be here, 1 upon x a power x differentiation a power x log a base e. Okay, let's say in 1/6 number formula I am writing dy dx of log x base is not written, let's say log I am writing base a, then its differentiation will be different, 1 upon x will be no problem, in denominator log a base e will be here. Okay, here what? Log e base e become 1, that's why I am writing 1 upon x only. Got it? I hope so clear this one. Okay, if it is clear, then no problem. Then some fundamentals I am telling you here. Let's say question is given in this format. Okay, that function power function is given, that let's say I am saying that differentiate given y is equal to x power x. Okay, and I am saying find dy by dx. Listen carefully. Okay, it is x is a function and power x is also function, means same function, no problem, you can write 2x if you want. Okay, x power 2x. I am saying find dy by dx. Okay, means differentiation of y with respect to x. So what you will do, both side you will write dy dx. Okay, so differentiating with respect to x, differentiating with the respect to x, what you will write, dy by dx is equal to dy by dy dx of x power x. Here dy dx of y. Up, you don't know this formula, then what, you cannot do anything in this one directly. Okay, so whenever function power function is given, first take log. Okay, first I will take log y is equal to log x power x. Okay, x power x, so it will be what, x log x. Here what, log y. This clear? Okay, so I'm coming to this question. Just wait, one more thing is required actually. Now let's say I'm taking some question, dy dx of sine x, you are saying cos x. Okay, let's say you are saying dy dx of find sine ax plus b, then what will be, then you will, then I will say to you that first remember this one, this ax plus b is looking like x type. Okay, x type only, just keep in mind that this is nothing but x, it is like sine x na, then keep in mind it is sine x, then its differentiation will be cos x, but x is not x, x is what, ax plus b. So whenever formula is standard type but x is not looking x, then take the differentiation in the similar way and again write into differentiation of if you are assuming that it is x, means this one again differentiation you have to do, ax plus b. This is called chain rule. Okay, so it become cos ax plus b into differentiation of ax will be what, a outside, x differentiation 1, b is constant, b differentiation 0, so it becomes a plus 0 means a, means it is a cos ax plus b. Okay, how it is happening, I'm telling you, let's call chain rule. Chain rule, how it is working, I'm telling you, d by dx f of, let's say, g of x is there, two functions are there, a composite function type, then it will be, first it will be f dash g of x, means as a function derivative should be like sine x derivative cos x, so right, cos gx is ax plus b here. Okay, similarly f dash means derivative of f dash and whatever the inside, write it, and again into d by dx of g of x. Okay, so this is the way, like example I am taking dy dx of again sine 5x. So you know the sine x only, here gx is 5x, correct or not, gx is 5x, or you can say sine x you know, and okay gx is 5x, so you will say derivative of what, sine x type, first what, you will say cos x, so not, it is not x, it is 5x, so cos 5x and again derivative of 5x will be what, 5 cos 5x. This is okay. Similarly, if I am writing dy dx of log 3x, then you will say okay it is working like log x, then log x derivative is what, 1 upon x, but it is not x, 1 upon 3x, and again dy dx of 3x, correct now, so 1 upon 3x and derivative of 3x will be 3x derivative 1, 3 outside, 3 cancel, 1 upon x you are getting. This is clear. Now let's say one more, I am saying that if you are finding derivative of, let's say, dy dx of uh, log x square, then what will be, then again you have to treat this is like log x, then 1 upon x, but it is not x square, and again derivative into dy dx of, because you assumed x square to x, that is not x, so again derivative of that one. First treat like standard formulas, after that if x is not means to whom you are saying x, that is not exactly x, then again write into derivative of that one. So it is 1 upon x square, derivative of x square is 2x, 1x power cancelled, 2y, x is the answer. Okay, now we'll come to that question. That question is saying y is equal to x power x, find dy by dx. So what I am saying, whenever function power function is there, then take log first both side, then log y is equal to what will be a x log x. Okay, now differentiating with respect to x, with respect to wrt means with respect to x, what it will be, dy dx of log y is equal to dy dx of x into log x. Now see, x is different function, log is different function. Log is logarithmic, log x means called logarithmic function, x is algebraic function, I told you. Okay, so means fx into gx, two function in multiplication, and here log y is here. So log y differentiation will be what? I said to you that treat it like log x. If log x, then it will be what? 1 upon x, but it is not x, it is y. So 1 upon y. Again, because it is not x, so again you have to differentiate this one, dy by dx of y, means dy by dx. And we want actually that one, dy by dx we want. So dy by dx is, after that what? First function outside, derivative of second function, dy by dx of log x plus log x, second function outside, derivative of x. So x log x derivative 1 upon x plus log x and derivative of 1, x is 1. So it become what? X plus log x, 1 upon y dy by dx. So from here dy by dx we are getting what we are? Y into x plus log x. It become what? X power x, because y value I can put x power x, x plus log x. Okay, it is clear to you all, I hope so. Okay, so let's see one more question in the similar way. Find dy by dx for given relation, given a relation y power x is equal to x power y. What I am saying, whenever function power function is there, then try to write what we have, first take log in both side. Okay, variable power variable or function power function. So take log y power x is equal to log x power y. Now you know that log a power m meaning what? M log a, m outside, log a. Similarly x will be outside, x log y is equal to y log x. Now what? Differentiation with respect to x. So taking derivative in both sides, dy dx x into log y is equal to dy dx of y into log x. Okay, what it will be? First function outside, two function here, log and x. So x outside, derivative of what we are, log y, and is equal to y, sorry, and plus second function outside, log y into derivative of first function x is equal to, similarly here first function y outside, derivative of log x, correct or not, plus log x, second function outside, derivative of first function dy dx of y. Dy dx of y means dy by dx, and dy by dx only dy by dx, we want that one actually, dy by dx. Okay, see, so this is x, and again derivative of log y will be what? Treat is like x, so 1 upon x, but it is not x, y, 1 upon y, that's why again derivative of this one, dy by dx plus log x, derivative of x is 1, you know, sorry, log y, this one is log y, derivative of x is 1, so nothing is going to change. Okay, log y into 1 is equal to y log x derivative 1 upon x plus log x outside, okay, into dy by dx. Keep in mind that it is in whole multiplication, log x into dy by dx. Now what we want, dy by dx, so collect dy by dx. Okay, write this dy by dx in this side. So x upon y minus log x, this one. In both I am taking dy by dx common in these two. Dy by dx common. It become what? Y upon x minus log y. I hope so, no problem in this one. After that, what we have? Just dy by dx. You have to write dy by dx will be what? Multiply it y minus x log y upon x, and total upon this one x upon y minus log x. Okay, so solve it. Just now simplification, y minus x log y upon x. I am leaving that one. Okay, write that one upon x upon x minus y log x upon y. So this will be, this will be upside here. Okay, it will be flipped, in change in multiplication, this one divided by this one. So y minus x log y into y. Okay, and here it will be what? This one, and it will be numerator x into x minus y log x. This is the answer. Okay, so in this question you will say, sir, it is in format of xy. Yes, this question is like that actually. Okay, dy by dx in format of x comma y. We got our answer. Okay, I hope so. In this one, no any problem is there. Let's say one more. I'm writing question. Okay, dy dx of um, cos x power, let's say sin x, you want to find. Okay, then what? First assume that y is equal to what? Cos x power sin x. First assume this one. After that, take log. Whenever I'm saying, whenever function power function, then log. By log you have to, by taking log, then you have to differentiate. Sin x outside, log cos x by taking log. Okay, after that, differentiate it. So again, differentiation of log y will be 1 upon y, and it is not x, that's why dy by dx. And same way, first function outside, second function derivative. Okay, let me do this one. Okay, first function outside, derivative of log x, dy dx of log cos x plus log cos x outside into derivative of what we are, sin x, correct or not? So it will be what? Sin x derivative of log x. You don't know log cos x, then treat cos x like x, and it will be 1 upon cos x into dy dx again of what? Of cos x, because you are saying that this is x, this is not x, plus log cos x into dy dx sin x, that is cos x. Okay, just solve it. Dy dx cos x, sin minus sin x. So sin x into minus sin x upon cos x plus cos x into log cos x. This is the answer. Okay, I hope so. This is clear to you. Let's see. One more type of question they may ask to you. Okay, I'm writing one question, that cos x plus y is equal to log x plus y. Okay, find dy by dx. Find dy by dx. So in this one, nothing you have to do, just a derivative both side we have to take. Okay, so dy dx and dy dx. Now dy dx of cos x, this is x plus y. So in the similar way, standard, try to remember standard, this is working like x, then it will be sin x, but it is not x, it is what? X plus y. So write whatever is written, treat in mind this is working like that, what? Cos x derivative sin x. So sin x plus y, but it is not x, that's why again a derivative of what? To whom you assumed x, means x plus y, is equal to dy dx of, you don't know, log x plus y. So you know the log x derivative, that is 1 upon x. I will treat it like x, then 1 upon x. X means x plus y, because it is not x, that's why again derivative of x plus y. I hope so. This is clear to you. Okay. From here, what will get? Sin x plus y into dy dx of x is what? 1 plus dy by dx. This side. Here 1 upon x plus y, and dy dx of x first function, that is 1 plus dy by dx, derivative of second function. Dy by dx we have to collect. Okay, so multiply it, sin x plus y plus sin x plus y into dy by dx, okay, is equal to 1 upon x plus y plus 1 upon x plus y into dy by dx. Okay, collect dy by dx. This time I am taking this side, this time I am taking that side. So sin x plus y dy by dx I am taking common, and this term will be here minus 1 upon x plus y. Okay, dy by dx is equal to 1 upon x plus y minus sin x plus y. Okay, this is a cross multiplication and solve. Here x plus y sin x plus y, okay, minus 1 upon x plus y dy by dx, correct, is equal to here also 1 minus x plus y sin x plus y upon x plus y, correct now. So you can see that dy by dx will be what from here? Dy by dx is 1 minus sin x, 1 minus, 1 second, 1 minus, good question actually. Solve it, then you have to go. Maybe this type of question may appear in the exam. 1 minus sin x plus y sin x plus y upon x plus y. Okay, you are going to divide by this term, correct or not? It will be converted into multiplication. In that one it will come by this, no, that will be converted into multiplication. How? X plus 1, this term will be in upside, x plus y upon x plus y sin x plus y minus 1. See, x plus y cancel, and these two terms are just opposite of each other, negative of each other, correct or not? See, this is x plus y into sin x plus y minus 1, and if I am taking minus here common, then it will be what? Minus here common, then it will minus, it is plus, same, cancel, means it is minus 1 is the answer. Dy by dx you got what? We are minus 1. Okay, so this question you can see it is nothing in this one, just a derivative you have to take. After that just solve it. Okay, I hope so in this one nothing, no any problem is there. Okay, one more thing, just a few minutes more, after that this is done. Let's say I am saying that y is equal to log, find derivative of under root 1 plus x square. What you will do? Okay, so you will say, okay, dy by dx is equals to dy dx log under root 1 plus x square. You will say, whatever sir will look like here log inside, I will treat like x first, and I will take a derivative like log x type 1 upon x, but this is not x, so that I will write 1 under root as whatever 1 upon under root 1 plus x square. Again derivative of, you will say, sir, I have to take derivative of this one by chain rule because it is not x, 1 plus x square, correct or not? Now again just you have seen that dy dx of root x is equal to 1 upon 2 root x, correct or not? So that will work here. Again you will say, sir, it is working like root x. Okay, in my mind it is a root x type, it is, I am assuming that this is x, so it will be what? It will be 1 upon, this is okay, no problem, 1 plus x square, it is working like root x, so I will write its a derivative 1 upon 2 root x. Okay, means 1 plus x square at the place of x, and again because it is not x, so I will write derivative of this one again, dy dx of 1 plus x square. So from here what will be 1 upon root 1 plus x square, root 1 plus x square will be 1 plus x square into 2 is here. Okay, and dy dx of 1 plus x square will be derivative of 1 is 0, and x square derivative 2x. Okay, so it is what? 2x upon 2 1 plus x square, this 2 cancel, x upon 1 plus x square, that's the answer. Okay, let's say here some more function is there, x plus something, y plus something, xy, let's say x square plus something, then what, accordingly you have to take derivative. Let's say one more I am writing, 1 y equals to log x plus, let's say x plus same thing I am writing. Okay, so that derivative of that one we can take first, 1 plus x square. What was 1 plus x square? Yeah. So what will be its derivative? Its derivative will be, you tell me, dy dx here also, and dy dx. You want dy by dx, so it is dy by dx this side, no problem. This side you will say that I will treat like this is total log x, this is log x, then 1 upon x, x plus under root 1 plus x square. Again you will say that sir it is not x, that's why again its derivative we have to take dy dx of x plus log x plus under root 1 plus x square. So derivative of first function plus second function, derivative will be separated, 1 upon x plus under root 1 plus x square, dy dx of first x derivative, you know 1, x derivative is what, 1 plus dy dx of this one you just did 1 upon 2 under root 1 plus x square first, again derivative of this 1 plus x square is 0 plus 2x. Okay, this 2 cancel here, and um, yeah, you got your answer. Okay, this one. So it become what, it become 1 upon x plus under root 1 plus x square into 1 plus x upon under root 1 plus x square. Okay, just multiply, cross multiplication, 1 upon x plus under root 1 plus x square into under root 1 plus x square here, plus x upon under root 1 plus x square. This one cancel, 1 upon under root 1 plus x square. I hope so clear to you, and this one no problem. Let's say it is saying that find y of 0, meaning what, find the dy by dx at 0, at x is equal to 0, or it may be that dy by dx y 0, meaning what is the value of dy by dx when x is 0, then put here what is the dy by dx when x is 0, put here 0. Okay, one more thing, some notation is there via, some notation like if you are writing dy by dx, then sometimes it will be written as y1. Okay, okay, again you are taking derivative of derivative, dy by dx, let's say I am taking derivative of dy by dx derivative, then it is called second time you are taking derivative, second order derivative, means second time you are taking derivative of one derivative, that will be d2y by dx square, d2y by dx square. Similarly it is called second order derivative, second order derivative means again you are differentiating that one. Let's say you are differentiating this one again, dy dx of d2y by dx square, then it will be written as d3y by dx cube. Okay, third order derivative means third time you are differentiating the same function. Clear? I hope so this one clear to you. So one question will take, and after that I'm stopping here. Okay, dy dx of, let's say dy dx of, I'm saying that find log cos x, even not dy dx, let's, one second, I'm saying let y is equal to log cos x, let's say whatever, sin x cos x. Okay, find d2y by dx square. Okay, meaning what, second order derivative you have to find. First you have to take dy by dx, again you have to differentiate that one with respect to x, means first time differentiate dy by dx with respect to x, here also dy dx of log sin x. One thing will be in your mind, you will say sir I will treat it like x, then log x differentiation 1 upon x, but it is not x, sin x, so that it's again derivative I will write dy dx into sin x, it is what, 1 upon sin x into cos x. Okay, derivative of sin x, cos x upon sin x become cot x. Okay, you can write here cot x. So from here you are getting dy by dx is equal to what, cot x. Again I will take derivative of this one, d by dx of dy by dx, okay, is equal to dy dx of cot x. You said this one d2y by dx square, and this is cot x derivative minus cosec square x. Okay, so hope so you're doing well, and go and do your paper. One type more question maybe like if I'm writing y is equal to, let's say, under root x plus under root x plus under root at the place of x may be something different, means idea is similar, plus dot dot up to infinite term. So you tell me, if one, this one, if I am removing, then anything is going to change in this one? Nothing. You will say, sir, it is if I am removing this one, then this is again looking like same thing, correct or not? Because it is going up to infinite term, means here if I am removing this one, then nothing is going to affect, meaning what? I can assume this term, this whole term I can assume what? This whole term I can assume y, correct or not? Tell me, this whole term I can assume y. How? Let's see. Means from here y is equal to, I can write x plus, because this is under root x plus under root x plus under root x up to infinite time, and is also written under root x plus under root x plus under root x infinite time. From here I am starting, this one will be y, x plus y. Now I will find dy by dx. Okay, now I will find dy by dx. Dy by dx we have to find, take derivative with respect to x. Dy dx of y is equal to dy dx of under root x plus y, correct or not? So you will say, sir, this is dy by dx required, and here under root x type derivative 1 upon 2 root x, but it is not x, it is what? X plus y. Again derivative of what? To what? To whom you assumed x, means x plus y. From here dy by dx is equal to 1 upon 2 under root x plus y, and derivative of x is 1 and derivative of y dy by dx. Now after that dy by dx you have to collect, dy by dx is equal to 1 upon 2 under root x plus y into 1 will be same, plus 1 upon 2 under root x plus y dy by dx. Take dy by dx in one side, so here 1 is there, so 1 minus 1 upon 2 under root x plus y. Okay, dy by dx is equal to 1 upon 2 under root x plus y. Okay, just multiply it, 2 under root x plus y minus 1 upon 2 under root x plus y dy by dx is equal to 1 upon 2 under root x plus y. Okay, 2 under root x plus y, if you divide it will be cancelled, it will be in denominator only. Dy by dx you are having what? 1 upon 2 under root x plus y minus 1. So this is the answer. Okay, some last one you can see that let's say it is written dy by dx find of tan inverse sin x cos x plus sin x upon cos x minus sin x. Let's say this one you want to find. So you know this one, what? This one is what we in tan format you can write. In trigonometry you have seen d by dx of what? Tan inverse. I can write this one, what? Divide by cos x in numerator and denominator, 1 plus tan x upon 1 minus tan x, and 1 I can write tan pi by 4, then tan pi by 4 plus tan x upon 1 minus, I can write here, see, dy dx of tan inverse. Firstly, this in this type question, first solve this one, try to make tan. So I can write this one, tan pi by 4, that is 1 plus tan x upon 1 minus, I can write here 1 into tan pi by 4 into tan x, correct or not? So it become what? Tan a plus tan b upon 1 minus tan a tan b equals to what? We are dy dx of tan inverse tan a plus tan b upon 1 minus tan a tan b equals to what? Tan a plus b, means tan pi by 4 plus x. Okay, so this is what? Tan inverse. I told you that just keep in mind tan inverse tan Mr. X will be what? Mr. X. Okay, so dy dx of what become pi by 4 plus x. Okay, pi by 4 differentiation 0, x differentiation 1 is the answer. Okay, so thank you. Try to listen this one properly and go in a, you when you are writing your paper, you don't have to be very hurry that okay, in just a minute I will solve. Okay, means slowly you have to solve the things. Okay, and you will get it, don't worry. Okay, slowly means whatever question in question you are feeling easy, those question try to solve first. Let's say only third 20 question you knows well, then solve that one first. Okay, in let's say 2 hour you are solving 20, no problem. Slowly you will grow. Like, see, you are here, then next day you may be here, maybe here, then here, then here, then here, next year maybe you will be here, and let's say here it is J, just some more effort you will jump here. Correct now? So okay, take care, god bless you all.